Hi there. Thank you for joining my session. Today, we will talk about machine learning and security. So the title of my talk is Hacking and Securing Machine Learning Environments and Systems. So to introduce myself, I am Joshua Arvin and I am the Chief Technology Officer of NewWorks Interactive Labs. I'm also an AWS Machine Learning Hero, and I am the author of the book Machine Learning with Amazon SageMaker Cookbook. So if you're interested in doing some hands-on work on performing machine learning experiments and deployments in the AWS cloud, then this may be the book for you. So enough about myself and enough about my book. Let's now go straight into talking about machine learning and security. So let's start first with machine learning and the machine learning process. Let's say that we want to build and deploy an image classification model. It's a machine learning model where we pass in, let's say, an image of a cat to the model. And what you want your model to do is to check if that model is a cat or not a cat. So if it is a cat, the output should be 1. If it's not a cat, then the output would be a 0. So it's your machine learning model is able to perform some intelligent task that it's programmed to do. So there are other applications of machine learning. Let's say sentiment analysis. Let's say you want to perform forecast. You want to perform some regression and classification. Then you would be able to do that with machine learning. So in order to build models, you would of course need data. And in order to be able to perform and build that model, you have to follow a process called the machine learning process. So you can see in the screen a simplified version of this process. And again, you would need to start with data. So most of the time, in order to have a model, you would need to have data in order to train that model, especially for supervised classification requirements. So here, we can see that you start with data collection. Next, you prepare and clean the data, you visualize it, and then you perform feature engineering in order to prepare your model, in order to prepare your data for model training. Once your data is ready for model training, you use certain algorithms and you perform and provide specific parameters and hyperparameters to train and tune your model. So you would produce a model which can then be used to perform predictions or inference. So at this point, now that you have a model, if you have a new data or new set of records, you can now use those records as input and your model can be used to perform specific predictions. So after you have a model, you need to perform model evaluation because the goal of your model is to be as accurate as possible. Let's say you have an image of a dog. You don't want your image to tell you that it's a cat. So the goal is for your model to make as many correct answers as possible. And that's the goal of model evaluation. So once you're happy with your model, you now deploy it. So that's the basic machine learning process. That's the simplified machine learning process. And in real life, you would encounter requirements where you will have to perform redeployments, meaning that you have an existing model in place, and then given a new data set, or an updated data set, you would have to train a new model, compare it with the previous one, and then you can replace it and ensure that there's zero downtime. So as you can see, this entire process involves both machine learning and engineering. That's why there's something called machine learning engineering, where you have to take care of the infrastructure, you have to take care of the application in order to deploy and host and manage your models in production. In order to make the lives of data scientists and machine learning engineers easier, a lot of machine learning practitioners make use of specific frameworks and platforms and services in order to automate certain parts of the work. For example, instead of building your own custom solution using custom scripts, custom formulas, we can basically proceed with using scripts or even services which can help automate the work for us. So as you can see in the screen, this is an example of how a service like SageMaker is used to compute for certain metrics like the class imbalance scores, DPPL, and treatment equality, so that we can easily analyze and understand our data and the model. So this is very helpful when it comes to dealing with requirements, when it comes to fairness, and you can technically use SageMaker also to analyze models and how it behaves, especially when you're dealing with, let's say, neural networks. If it's hard to understand how your model works, maybe you can check its behavior through different means and through different formulas. Now that we have better understanding of the machine learning process and the different approaches, especially with the usage of services and platforms, let's proceed with talking about security. When thinking about security, usually people think of the best practices. People think that when they follow the best practices, they think that their application or their infrastructure would be secure. Unfortunately, this is not the case, because in order to know if your system is secure, you have to test it. This is very similar to testing, load testing. If your client asks you, can your system support 100 clients or users at the same time? You cannot just say, yes, it can support it without actually testing it. So what we want to do here is, if we want to test if something is working or not, then we literally have to use certain set of tools and processes to test and validate our own assumptions. So in the case of load testing, we use a load testing tool. If we're talking about security testing, we use the appropriate set of tools. We may use the security scanners, we may use certain tools to assess and check different vulnerabilities of our application and infrastructure. And that's basically part of the tool chain and toolkit needed to assess your environment. At the same time, it's important that we keep in mind that we are trying to protect our system from attackers. So we have to assume the role and the mindset and approach of these hackers as this is for them a game. This is for them a puzzle. And they will be given a set of resources to attack. And they will follow a certain set of protocols and processes in order to understand the environment and perform a sequence of attacks. For example, if they're given, let's say, 5 servers, the first thing that they'll check is, what's visible to me? What can I easily access? Is this system configured properly? Which systems can I attack right away? If a hacker is able to attack a certain server, if that hacker is able to, let's say, get access by exploiting a certain set of vulnerable resources, would they be able to perform privilege escalation next? And so on. So after exploiting one of the vulnerabilities and having access to the servers, they may try to use that server to access the other servers in the infrastructure. So once they are able to reach the inner ones, the servers which have direct connection to the databases, then that's the time they will try to extract the data. They might try to steal the passwords, or they might try to extract everything from that server and send it to their own machines. And that's their way, that's where they will use other tools to maybe get the passwords or maybe use the data to attack other systems. Finally, they may use the other servers they have already compromised to attack other servers as well. So again, there are a lot of things which can be performed by attackers. So from your point of view, if you want to secure something, you have to understand how your systems can be attacked. At the same time, you have to assume that this will be a combination of attacks. Some attacks may be performed and directed towards the human entities, meaning the employees. So if an employee gets attacked, maybe one of your colleagues may receive an email, and then when that person opens a link in the email, then his or her machine would be compromised already. So that machine may have access to an internal network, and that's where the attack may happen. So again, there are different areas and different things an attacker will do. So it's better that you are prepared on what's possible whenever you're trying to protect your system. So a lot of companies know this. But in real life, in practice, this is usually not the case, as a lot of companies often deprioritize security. For one thing, they would prioritize the short-term financial objectives and the long-term financial objectives because there's nothing to secure if there's no business in the first place, right? That's how people think. At the same time, it's already hard to keep the client and the customers happy. So in terms of like the ratio and the focus areas, your company may spend or may have 90% or 95% of the entire population of the entire team focused on the first 2 or 3 objectives here, right? Short-term financial objectives, long-term financial objectives, and client and customer happiness, because that alone is already hard. So if we add more things to this list, of course, that would be deprioritized. And that's what's happening usually to compliance, to security, even to the operational excellence part. A lot of these things get deprioritized, and it's our duty to remind everyone how important security is, because if your data gets hacked, if your systems get hacked, and your data is stolen, then there's a big chance that your company might close. Because, of course, if the passwords and the credentials are stolen, and your customers get affected, then customers would lose trust in your company. So be very careful about this topic, because security is a complex field and it's super hard to secure systems. That said, you need to have the right mindset and the right strategy when securing ML systems and environments. So when talking about machine learning and machine learning engineering projects, we have to understand what's available to us. We have to understand what hackers would want. So here, we can see in the screen that we have control of the custom implementation aspect. If we have custom code, if you have custom scripts, then yes, that's in our control. That's under our control. That's under our responsibility. We have to make sure that everything we put inside that platform or service is properly checked and secured. At the same time, we have to ensure that the service or tool that we're using is properly configured. A lot of attacks are performed on misconfigured servers or systems, so it is important that we properly secure this as well. So the ML service that we will use, or if we're not using an ML service, that's critical also, because the type of security strategies that we will implement depend whether we're using an ML service or not. So let's say that we're using TensorFlow or PyTorch or MXNet on top of a server, like an EC2 instance. Then there, we're making use of an open source framework to run training experiments and deployments inside a server we can control. So the hardware is managed by AWS, right? So we don't need to worry about that, because that's being taken care of AWS themselves. At least when you're running machine learning experiments on AWS. So what about the operating system and the applications inside that server? We need to take care of that, because that's under our control. So there's something called a shared responsibility model, and that model should be similar across all the other different cloud platforms. So make sure you know which ones you need to take care of, and you also need to make sure that the different services and tools are configured properly. So now, it's time we think like a hacker. All right, so let's try to do a quick simulation. And let's say that we have this network. So there's a public subnet, and then there's a private subnet. In the public subnet, we can have there the web servers, and those web servers are accessible globally. So the outside world can access everything inside the green region. And in the blue region, the private subnets, we have there the database servers. So of course, since the data is should be protected, those are stored inside the private subnet. So if you were a hacker, of course, you cannot directly attack the ones in the private subnet. You would probably have to look for the servers in the public subnet first. So as you can see, we have already highlighted and put a box and tagged it as high risk because anyone can access that, including the attackers. They will try to run different scripts. They will use different tools to assess the security of the server and the applications running there. And then they will perform an attack. If they are able to compromise that, that server will be used to attack the other servers. So what you need to do is to add multiple layers of security to secure the different aspects of your application. And you need to prioritize what's highlighted and tagged as high risk. So that's the reason why the green area, the public subnet, is tagged and sometimes labeled as a DMZ, a demilitarized zone. So you need to protect everything in that DMZ. So now let's try to implement the same set of concepts in our machine learning process and in our machine learning environments. So here are some of the applications and services and tools a machine learning practitioner would use. Of course, if you're a data scientist or a machine learning engineer, you may be using Jupyter notebooks. And that Jupyter notebook will be running on infrastructure such as servers, right? Or instances or virtual machines, right? In some cases, you will have an ML service to help you manage running this notebook instances for you. So on top of that Jupyter notebook, you will be running custom code and you will download the datasets. So in terms of like the color convention here, you will see that the ones in white are the ones you can control. And if you're not able to manage these things properly, then hackers may be able to take advantage of that and use it to compromise your system. So how would that work? If your infrastructure is something that is valuable to hackers, maybe they can run some Bitcoin mining stuff there. They may try to write some malicious code or write some malicious scripts inside some of the packages and dependencies that you may use. So when you run your scripts, suddenly the hacker's malicious code would run as well. And what will happen is your hacker would be able to run things inside your infrastructure, and out of nowhere, the entire infrastructure has been compromised already. So how are hackers able to do this? They are able to do this by adding some payload, which let's say opens a port. So if there's a server, maybe before the script is executed, let's say port 4000 is closed. So when you run your script, the malicious payload runs as well, and then suddenly port 4000 is open. So your server's port 4000 has been opened by the malicious payload. Now, your hacker, since it knows that that port is open, he will now connect to your server and he will be able to run commands as if it was his or her own machine or computer. So if your hacker wants to download scripts, if your hacker wants to navigate through the files, if your hacker wants to steal the passwords and the data, then that is now possible. And if the machine that you have has excessive permissions, then it may be able to do other things like delete resources, it may be able to create resources, and so on. So be very careful because usually the cloud environments have something called roles. Roles and security entities which allow them to perform operations without API keys. So be very careful about that because hackers may be able to use that either for privilege escalation or for performing malicious actions. So this is one good example. So let's say that you decided to use a pre-built model prepared by someone else, someone that is outside your company. So that means that instead of using your own data to train a model, you would be making use of a model trained by someone else so that all you need to worry about is model deployment. So when you're writing custom scripts, you would probably use something like this where you use a library and then you use the load method or function to load a pre-built model so that you can use that model for prediction or inference, right? So what if that model had a malicious payload or an instruction similar to what I discussed earlier, and then when you run the code which loads the model, then suddenly your infrastructure and your application gets compromised. So what you need to do is you have to review each of the libraries that you're using and how it impacts the security of your system, especially if there are known vulnerabilities and issues like this. So make sure to read and look for the documentation sites because these are usually documented either here or in the issues or security section. So now, when you're talking about machine learning and machine learning services, what you need to do is you need to know what you're trying to do and what you're trying to prepare. So when you're running training jobs in the cloud, you may use a machine learning service which converts input into output. And the output would be the model artifacts, which can then be loaded later on to perform predictions. But before you are able to reach that point, you will need to pass in different parameters. So that includes the dataset, that includes the custom code, and then in some cases, you're given the opportunity to update the environment and prepare your own custom container image so that if you were to use a library, like let's say the Transformers library, you would be able to use the Hugging Face stuff inside your training jobs. And at the same time, you would have to add and provide the configuration parameters. So the one in the black box, that's something that you usually are not able to control and manage. So all you need to worry about would be the inputs and the outputs. So in some cases, you might think, hey, I'm going to use a custom container image. I'll just use something which has been built by another entity. You have to be very careful because if there's a malicious process or a malicious application or script running inside a container from that container image, then if you run the training job, then the training job server might get compromised. And if the permissions and roles assigned to that server is a bit too powerful, then the malicious script may be able to perform actions like, let's say, deleting different resources in your account or maybe creating new ones. It may be used to even perform privilege escalation from an account level. So be very careful because these input parameters are also the areas where your hacker might insert a payload or a malicious script. So when it comes to deployment, there are different options in different cloud platforms. And what is important is that the different types of attacks would also differ depending on where you deploy your model. So now that we have the model artifacts, now that we have already trained a model, it's now time that we build and deploy that model into its own inference endpoint. So what's an inference endpoint? An inference endpoint is simply maybe a web API where a model is hosted. So what your custom code would do, if it's not automated yet by the ML service, is your custom code would load the model, and then when there's a new request containing the input payload, the loaded model object would be used to perform a prediction with the input payload as the input, and then it would return an output back to the caller. So let's say that your model is an image classification model. If the input payload contains an image, then the output should either be a 1 or a 0. So if it's a cat, it's a 1. If there's no cat there, it's a 0. So that's basically the goal of your inference endpoint, to just provide a web service accepting the input and returning the output as the response. So in some cases, an ML service would provide more flexibility, like allowing you to introduce a custom container image. So if you are using certain libraries and packages, this is very helpful. However, you should be careful because similar to the previous example, you shouldn't use a container image provided by other entities. At the same time, your custom container image may include packages and installed tools which may be vulnerable. So let's say that at this point, your custom container image and the libraries installed there may have no vulnerabilities, but after 1 year, maybe new vulnerabilities would be discovered, and yeah, your inference endpoint would be vulnerable to different types of attacks. So make sure that your custom container images are scanned and check for vulnerabilities and weaknesses and risk. So at this point, you will be asking me, hey, how about machine learning pipelines? We're running this automated pipeline, and would the same set of concepts be usable when it comes to ML pipelines? The answer is yes, especially if your pipeline involves, let's say, a controller, and then you have a different set of resources running the jobs. So let's say that your training job is running inside a server, and then your deployment step would, of course, provision a dedicated ML inference endpoint. So those would involve resources, and those are areas for attacks. So a pipeline simply just automates the entire process, and you should be protecting the resources involved in the ML flow, in the ML pipeline. At the same time, you also have to harden and configure the security settings properly for the tool used to manage the pipeline. For example, if you're using Kubernetes and you're using some other open source tool to manage the ML flow and the ML pipeline, then you also have to configure and tweak the different open source tools and the different services that you're using to manage this entire workflow. Because that will be an opportunity or an area for attack as well. So now, we have talked about a lot of things when it comes to attacking different ML environments and systems. Let's now talk about the different solutions available in order to secure this. So the first practical way to secure a machine learning environment or system is to enable network isolation. So what do we mean by this? So network isolation is very powerful, especially if you accidentally use a script or maybe a container image which has malicious code or a malicious payload. Usually, when you're performing training with a specific algorithm, so you have this training job, and then your training job would be running a custom set of scripts or maybe a custom container. Generally, that script or app or container would not need internet connection. So if network and isolation is enabled, the malicious code or the malicious payload or scripts would not be able to connect to the outside world. So it will not be able to send requests, it will not be able to transfer your data to some other server, or it will not be able to download additional malicious scripts. So this is how powerful network isolation is. Because if you're trying to train XGBoost, for example, why would your XGBoost script download other things, right? Ideally, it's already self-contained whenever you're running training jobs. If, let's say, you're using something like distributed model training, so let's say instead of one server, you're going to train a model, but you're going to use multiple servers instead. Ideally, network isolation still allows those different servers to talk to each other while training the model. And then, those servers, that cluster, is protected from the outside world. So yeah, if this is properly configured, then yes, this would help prevent different types of attacks, especially if there's a script which tries to connect to the outside world without your permission. At the same time, if you have something like a CI/CD pipeline, then make sure that there's the manual approval step whenever possible. Because if everything is automated and nobody is checking it manually from time to time, then out of nowhere, maybe your application will already have code that attacks other users or customers. You do not want everything to be super automated that you're already forgetting about the manual processes and audits required to check the stability and security of your website. So in some cases, your website would be used to attack other customers. For example, your website would be used to redirect users from your current website to some other website which has a lot of viruses or things that will automatically exploit the browser weaknesses. So there are a lot of other attacks like that, and a simple redirect by a malicious payload can already cause a lot of harm. So make sure that your CI/CD pipeline, if it exists, would have this manual approval step. In addition to this, it's better if you can automate vulnerability management. When talking about vulnerability management, you might probably be thinking of a security scanner. So you have a web endpoint. It may be your machine learning inference endpoint. So you run a scanner there, and then your scanner would then list down all the different vulnerabilities and weaknesses of that endpoint. If there are misconfigured parameters and so on, your scanner may be able to detect it. But there may be a better way to do this. For example, what if you have a vulnerability assessment tool which not only scans a system from the outside, but it also scans the system from the inside? So for example, if you use something like Amazon Inspector, it would automatically scan the servers and the container images. So if you were to use a container image for machine learning training or machine learning deployment, then if, let's say, your custom container image contains a vulnerability or some other risk, or maybe a library which has a vulnerability, then your vulnerability assessment tool would be able to detect that even before it gets deployed. So that's pretty powerful because a tool like Amazon Inspector would be able to run automatically every time there's a change. So if your server changes, Amazon Inspector would run. If a new container image gets pushed, then it would run again. So all you need to do is check the list of vulnerabilities here. You need to process each one at a time, and then you have to list down the different solutions and remediation steps. It is important to note that this is something that you need to spend time on, because for one thing, you might see 1,000 or 5,000 vulnerabilities. So you need to sort it first. You need to assess which ones may be exploitable. And you also have to check if your application will break if you were to remediate some of these risks and vulnerabilities. Next, let's talk about infrastructure as code. So here, we have our infrastructure. Instead of us trying to deploy things manually, one resource at a time, and updating these resources, we can simply convert our resources into code. So what's happening here is that we try to divide our infrastructure into layers. So the resources, the security configuration, the network configuration, and so on. And what we want to do here is we want to convert it into layers of templates. And these templates can be used to generate automatically different types of environments. For example, if you want to have a staging environment, instead of manually creating those environments, we use that template as a reference to automatically build these environments. So there's, of course, a service which converts a string template to real resources. If you need a production environment created or updated, we use a template as reference as well. So if you need a new environment for manual penetration testing, instead of the manual penetration testers attacking your production environment or even a staging environment that your developers are using, you can create an environment, a dedicated environment for them. If you need an environment for load testing, then yes, you can create a dedicated environment for them as well. Once you're done, you delete it. So again, this is a very powerful tool. And if you're going to test and deploy security configuration updates or upgrades, it's better to do it this way so that you may be able to roll out things properly. So let's say that you have improved the security configuration of your network infrastructure. Instead of deploying it first in the production environment, maybe update the template first and have it used to update the staging environment. So now, if your application is still stable and working, that's the time you update the production environment, and so on. So this is something that you can use, and you can even create and manage the security resources and IAM configuration using infrastructure as code concepts. Account action monitoring. it's hard to prevent attacks. It's hard to troubleshoot problems if we're not able to monitor things properly. For example, let's say that we have this serverless machine learning environment and project. So this machine learning endpoint, this ML inference endpoint, makes use of an API gateway, a serverless API gateway, and a Lambda function. So a Lambda function is where you can write custom code. And even if you think that it's serverless, there's no server to attack, it can still be attacked because your code may be vulnerable to different types of attacks. So what happens here is that your hacker may input some payloads and instructions, and it will go straight into your Lambda function. So what you need to do is you have to ensure that you're able to collect the logs and you're able to analyze the logs quickly. If you're able to introduce a tool or a logging mechanism or system to help process the different logs, then that would help you detect security attacks earlier. Right? So you need something in place because it's best to not assume that your system is secure. It is best to assume that somebody will always try to attack it from the outside or from the inside. In addition to this, we have to restrict the IAM permissions. We have to ensure that we limit what different types of resources are capable of doing. For example, there are different types of resources, real humans and infrastructure resources. So from an infrastructure standpoint, you need to take care of the IAM permissions on what these resources can do. And what we need to implement is the principle of least privilege. Because, for example, you have hardened your entire infrastructure. What if the password of one user is not secure? In the sense that maybe the password is just 1234567 If that has been attacked, then your entire infrastructure has been compromised because of poor permission management and poor security guidelines and enforcement. So you need to ensure this because the weakest link would always be attacked. At the same time, you need to train the professionals working in your team because professionals are generally trained to build something or to perform their task at hand. However, you also need to worry about the last 50%. So what do I mean by the last 50%? The first 50% would be doing what you're supposed to do. The last 50% would be configuring and properly using a tool in a production setting. Meaning, it needs to be scalable. It needs to be something you can easily troubleshoot. And it's something that's hardened and ready for security attacks. So if you're using a tool, developers would generally just assume that the thing that they have built in their local machine can be directly deployed to a production environment. That's completely wrong. Because a production configuration is more or less super different compared to how it looks like when you're running it locally. So make sure that you have specialists and experts in your team to properly configure the security settings and implementation before going into production or staging. So before we end the talk, let's talk about cost. Because we have talked about a lot of things, a lot of best practices. We have to divide it into maybe 2 or 3 components or 2 or 3 buckets. The first bucket is the infrastructure cost, the additional infrastructure cost. And the second bucket would be, of course, the manpower required to work on these types of security requirements. The first bucket, you need to prioritize the free ones. Sometimes we always think, oh, we need a firewall, we need to spend this, we need to purchase this subscription or so on. In some cases, some of the small tweaks, let's say network isolation, you may be able to get that for free. A properly configured IAM setting or IAM configuration implementation, that can be free as well. So list down all the things you can do for free and then list down all the other moves you can do which may involve additional fees. For example, Additional fees may be involved when it comes to using another service. Let's say you're using a service which automatically encrypts data at rest, or maybe it automatically encrypts it on the fly, for example. If you were to use that service, that would add maybe 3% or 4% on top of the infrastructure cost. But if it makes sense, then proceed with that and have it approved. On the other hand, on the other bucket, when you're talking about manpower, you have to check on where you will get the resources focused to take care of the security. And you also need to make sure that there's a proper ratio. Maybe 80% would be builders and then 20% would be the maintainers. So the maintainers may be composed of the analysts, the ones taking charge of the processes and the management of the resources. So you have to follow a certain ratio, and you would also have to check if you're going to utilize internal team members or if you're going to work with other companies to help you. So, or maybe a combination of both. So always plan ahead, because once you're able to identify what you need, it is usually a long-term contract. So that would basically affect the overall cost. Because if you were to hire a company for 1 year just to audit your system, of course, you have to check, hey, how much is my system contributing to the final financial numbers in the first place? Is it worth it? Is it much cheaper to hire someone or to train someone from the team? So there are a lot of options, and you have to assess and choose which is the best collection of solutions, which is best for your team. So we were able to talk about a lot of things. We're able to start with discussing how to attack different scenarios and how to attack the different components and processes of the machine learning process, especially in how they are applied in a real life setting. Towards the second half, we were able to talk about the different security measures, because if we're not able to secure our systems properly, then the hackers and attackers would be able to take advantage of misconfiguration, and they would be able to steal our data and use our resources in ways that would either harm others or would harm us. So thank you very much. Thank you again for watching my talk, and hope you learned something new. Bye-bye.